All right, so going over the number one, well, this triangle, it looks skewed, but it's actually like on the floor. And so we're looking at it from a, like, I don't know, I guess unusual perspective, right? So it looks skewed, but it's actually a right triangle, right? So YXZ is a right triangle and ZXW is a right triangle. And how do we know that? Because we have this little box here. Okay, so since we know that YZ is congruent to ZW, because they're both the value of 5, then we know that XZ is a perpendicular bisector of WY, right? And via the perpendicular bisector theorem, we can say, oh, I'm sorry, not via the perpendicular bisector theorem, but because of the reasoning that we used in example number one, we can also say that xy is congruent to xw. Right? So if they're looking for xw, well, it's easy. It's a 7.5. And then for number two over here, this is exactly like example number two, right? We have a perpendicular line. The two sides are congruent. So because of that, we can also say that AB is congruent to BF. Right? So BF is going to be also 4.2. Okay. So next we have the circumcenter problems, and we need to know what a circumcenter is, right? Well, in this figure here, the circumcenter is this point P. And so what is a circumcenter? It is a point in a triangle that's created by the intersection of perpendicular bisectors. So a perpendicular bisector of EM, a perpendicular bisector of EK, and a perpendicular bisector of MK. So all three sides of the triangle. And where they meet, or where they intersect, is what we call the circumcenter. Okay. So if we're looking at this big triangle over here, well, how would we create a circumcenter? How would we find the circumcenter? Well, it's the perpendicular bisector of this line over here. So it's bisecting the line. That means cutting it in half. So if I'm going to eyeball it, that's about right there. And also it's perpendicular to this line over here. So it's has a right angle to that line. So I'm just going to go ahead and eyeball it like that, pretty much. Right? So that's a right angle there. And let's say that this side is congruent to this side. And then we have the perpendicular bisector of this line over here. So I'm just going to eyeball the middle right about there. Right? And I'm going to draw a line perpendicular to that line. So here's a perpendicular line. And then lastly, we're going to look at this line down here. And so I'm going to go ahead and eyeball the middle to be right about here. And then I'm going to draw the line perpendicular to that line here. Now, I didn't draw it exactly perfect, so the three lines don't meet. But let me go ahead and just draw this point here and then call it C for circumcenter. So that's how you find the circumcenter. It's the intersection of the three perpendicular bisectors of the sides of the triangle. Okay, so once we have the circumcenter, well then this theorem up here, the circumcenter theorem, kicks in. And what it states is that a circumcenter is equidistant from the vertices of the triangle. So you need to know what a vertice of a triangle is. And if we look at this triangle over here, the vertices are the corners of the triangle. So here's one vertice, here's another vertice, and here is another vertex. Okay, so the circumcenter theorem tells us that if we have a circumcenter, then it's equidistant, or it's of equal distance from the different vertices of the triangle, from the three vertices of the triangle. So this point C here, the circumcenter, is equidistant to this vertex, and also that vertex. So all of those lines are congruent. So I'm going to say that's congruent to that distance, and those two are congruent to this distance over here. Okay. So we're going ahead and looking down at this problem down here, and we're given the fact that P is the circumcenter of the triangle EMK. All right, so if that's the case, then we know some things about this triangle. first of all, we know that YK is a perpendicular bisector of EM. That means it's perpendicular and it bisects EM. So it cuts EM into two equal parts, right? So this side is congruent to this side. And that's all the way around the triangle because all of these lines are perpendicular bisectors. EN is a perpendicular bisector and RP is a perpendicular bisector of EK. So that means this side here is congruent to this side is congruent to that side. Just like over here in this triangle, this side here would be congruent with this side over here. Right? And then this side, I will make it with this line with circle, is congruent with this side over here. Right? It doesn't mean that this side is congruent to this side. No, 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 no. Okay? It means that this line here is a perpendicular bisector. It is bisecting this side into two equal parts. Okay? It's not setting this side equal to this side over here, or this line segment to that line segment. All right, just to be clear. All right, so that's going to help you solve these problems. And then we have question number 4, right? What's congruent to KP? And what is that? That is the distance from the circumcenter to the vertex K. It's not drawn in, right? KP is not drawn in the figure. But you want to ask yourself, okay, well, what is congruent with KP? Well, we got to go back over here to the circumcenter theorem, which states that the circumcenter is equidistant from the other vertices of the triangle, right? So if we're looking at this figure, it's this distance congruent to this distance, congruent to this distance over here. All right, so that's how you're going to go ahead and figure out number 4. And I'll go over the answers in the next video.